Hello. Hello, Niranjana. Can you hear me?
Good evening.
Good evening. Can you hear me?
Yes.
Right. Last time we discussed about the atomic structure in the last class.
Yes.
Right. So now are you confident about the electronic configuration? Hello.
Yes.
Okay. Just give me a minute, please. Okay. Do you have any doubt in that topic of atomic structure
No.
and electronic configuration?
No.
No. Okay. Now today we will start with the chapter of the periodic classification. Right. Have you heard about this periodic table in chemistry?
Yes.
Okay. What is the use of the periodic table?
It's where the elements are organized.
Could you please repeat? Yeah. Could you please repeat?
The el
Mhm.
the elements are organized in the periodic table
Right. How are they organized?
by their atomic number.
Okay. So, yes, Hamid, can you hear me?
Yes, sir.
Right. Hamid, today we are going to discuss about the periodic classification. And
Yes, sir.
in our last class, we did the atomic structure and electronic configuration. Are you comfortable with the chapter of atomic structure? Yes, Hamid. Are you are you quite comfortable with the electronic
Yes,
configuration? Hmm?
yes, sir.
Okay, fine. So, Hamid, you tell me, what is the use of the periodic table? In a 10th grade, I think you had done the periodic table, right?
Yes, sir. It is used to classify different elements
Mm-hmm.
in a specific category.
Mm-hmm. Right.
So, like each element is classified based on its atomic number.
Hmm. Okay. So, basically, the modern periodic table is based upon the electronic configuration. Based upon electronic configuration, right? So, atomic number and electronic configuration. After every particular atomic number, there is a repetition of the property. And so all the elements have been grouped in such a way that similar property elements are in the same group. Right? They've been classified as in certain groups. Okay. Do you know how many groups are there, Niranjana? In the periodic table, how many groups are there?
17.
18 groups are there, not 17. These are 18 groups. And how many periods are there, Hamid? Any idea? For a 10th class syllabus, I'm asking this.
Yes, sir.
Okay. Niranjana, what?
7 periods.
7 periods are there. Okay. 7 periods and 18 groups are there, right? Okay. Okay. So I'm now sharing my screen with you. Just let me know. Can you see my screen? Can you see my
Yes.
screen?
Yes, sir.
All right. If you have periodic table with you, either soft copy or the book, whatever, you can open that. If you have a book, that's better. Do you have the hard paper?
Yes, sir.
All right. And open the periodic table. I think in the chapter of the periodic table, this is given periodic table here. Modern periodic table is given. And it has been classified into 4 blocks: S block, P block, D block, and F block. S block consists of the 2 groups, group number 1 and group number 2. D block from group number 3 to 12 means 10 groups are there. And P block group number 13 to 18. Right? These are all like that. 10 groups are there in the D block, and F block like this. 2 things, 2 horizontal lines we can say. One is called lanthanoid, other is called actinoid. Okay. Can you see in your book also? I'm stopping sharing for a moment. Yes, Nanjana, do you have book? Hard copy? Something? In which you can see the periodic table, all the elements. I'm asking, can I see in your book? Do you have periodic table?
So I can see.
Okay,
Yes.
okay. So in the group number one, that is extreme left, which elements are there? Yes, Hamid.
Or hydrogen.
Continue down the group, not only just one element.
So hydrogen, then group, right?
Yeah.
Then there's helium.
No, you're going left to right. I'm going to say down the group. Down the group.
Uh,
Vertical lines are
the
called groups.
hydrogen,
Hmm. Lithium.
lithium, sodium, uh, potassium,
Hmm.
RP and CS.
Okay.
I don't know those ones.
Rubidium, cesium, francium. Right. Right. The vertical lines are called groups. And if you go from left to right, these are called as the periods. So vertical columns are 18 in number. 18 groups are there. Can you see that in the periodic table?
Yes, sir.
And horizontally, if you move, there are 7 periods are there. Right? You can see that. And can you see that the 4 blocks are there? S block, P block, D block, and F block in the periodic table? Or there is no such
Yes, sir.
no such instruction. Okay. Now we will be discussing physical and chemical properties down the group and along a period. First, I'm starting with the topic of atomic size. Now you can note down from my screen. You can now focus upon my screen now. Atomic size. What is atomic size? From the center of nucleus to the outermost electron. This distance is called as a atomic radius. Right? Understood? The distance between the center of nucleus and the electron, outermost electron, is called as a atomic size. Now, if we see down the group, how does the atomic size vary down the group? Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Atomic number 1, 3, 11, 19, 37, 55, 87. Niranjan, can you tell me the electronic configuration of hydrogen here?
One S1.
Good. Hamid, lithium,
Sir, 1s2,
2s1.
2s1.
Yeah. Niranjan, 11. Atomic number say 11, sodium.
Neon 3S1.
Neon complete, 3s1. Next, Hamid, yes, Hamid.
Sir, argon, 4s1.
Okay. Krypton, 5s1. Xenon, 6s1. Radon, 7s1. Right. You can see as you go down the group, the number of shells increases. 1, 2, 3, 4, and 5, and 6, 7. As you go down the group, number of shells increases. So atomic size increases. Am I clear?
Yes.
Yes, sir.
And now let us see across a period. I am considering period number 2. Check in the period table also. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Atomic number 3, 4, 5, 6, 7, 8, 9, and 10. And now tell me the electronic configuration of lithium. Electronic configuration of lithium. Quick, quick, quick.
1s2, 2S1.
1s2, 2s1. Beryllium,
1s2, 2s2,
boron,
1s2, 2s2, 2P1.
carbon,
1s2, 2s2, 2p2,
nitrogen.
1s2, 2s2, 2P3.
Good. So what you find here is as you move from left to right, the nuclear charge increases. Atomic number increases means nuclear charge increases. But electron enter into same subshell. Electron enter into same subshell. You can say 2s. Electron enters into same subshell. So effective nuclear charge increases. So attraction increases and the size decreases along a period. Along a period, size decreases. Yeah, understood. Note it down. Note it down. Understand? Go ahead.
Yes, sir.
Right. Now we talk about the ions and ionic radii. First of all, tell me what do you mean by the word ion? What do you mean by the word ion?
Atom with a charge.
Yeah, means we can say charged atomic species. Charged atomic. This ion is of two type. One is called cation, other is called anion. One is called cation and other is called anion. Word cation is formed by the loss of electron. If an atom A loses electron, it becomes positively charged. We call it a cation. If it loses n number of electron, it acquires n positive charge. And anion is formed by the gain of electrons. A atom gaining electron becoming A negative. If it gain n number of electron, it become n negative. Anion is formed by the gain of electrons. So in the center of the nucleus to the outermost electron in an ion is called as a ionic radii. If we have an ion, the distance between the center of nucleus and the outermost electron is called as a ionic radii. Understood?
Yes.
Right. Now, write down size of cation is less than corresponding neutral atom. Corresponding neutral atom. Suppose I say I have here sodium and I have lost one electron. It has got Na positive. Then the radius of the cation is less than the radius of the sodium. That's what I mean to say. right? Why it is less than that? Can you tell me any reason for this? Any particular reason for this? Can you tell me? There are two reasons you can see. Nuclear charge per electron. Nuclear charge for sodium is 11. Electrons are 11. So nuclear charge per electron is 1. But here nuclear charge is 11 and electrons are 10. So nuclear charge per electron is equal to 1.1. You can see the nuclear charge per electron increases, then every electron experience more attraction towards nucleus, and that is why the size decreases. So radius of the cation is less than the radius of the sodium atom. Understood?
Yes, sir.
Now, next write down radius of cation, radius of anion is larger than corresponding neutral atom. So I say chlorine is bigger than the chlorine. Understood? Why it is so? Because the chlorine after gaining electron becomes Cl negative ion. Nuclear charge for chlorine is 17. Electrons are 17. So nuclear charge per electron is 1. Electrons are 18. So nuclear charge per electrons are 0.9. So as the nuclear charge per electron decreases, attraction for electrons will decrease. And that is why the size will increase. Am I clear? Am I clear?
Yes.
Yeah. Keep on responding. Keep on responding. Because once I share my screen, I can't see your faces. Right?
Yes, sir.
So keep on responding. That's the only way I can just judge that you are there and I'm teaching you. Right?
Sir.
Okay. Now next. I'm talking about the next topic right on enthalpy of ionization. Enthalpy of ionization. This is an atom A. We are providing some energy to eject out the most loosely bound electron. So how much energy is required? That is called as the enthalpy of ionization, delta IH. Delta IH. Enthalpy of ionization. Delta IH as an enthalpy of ionization. Write down the amount of energy required to eject out the most loosely bound electron from an isolated gaseous atom. From an isolated gaseous atom. Amount of energy required to eject out the most loosely bound electron from an isolated gaseous atom. So this is the outer electron and the nucleus. Stronger the attraction between the nucleus and electron, it will be more difficult to eject out electron. And this attraction is an electrostatic force of attraction. Electrostatic force of attraction. This force of attraction directly proportional to charge on the electron, charge on the nucleus upon square of the distance between the two. So greater the force of attraction between the nucleus and electron, it will require more enthalpy of ionization. It will require more enthalpy of ionization. Right? It means enthalpy of ionization depends upon number one, size of an atom. Bigger the size, you can see as the size increases here. You can see the R is inversely proportional to F. If the size increases, the attraction will decrease. And the ejection becomes easy. It means enthalpy of ionization will decrease. Enthalpy of ionization will decrease. Or we can say enthalpy of ionization is inversely proportional to the size. The size is more, enthalpy of ionization will be less. So first factor that affect the enthalpy of ionization is the size. Do you have any doubt in it?
No, sir.
No. Second factor is the nuclear charge. Niranjan, are you clear?
Yes.
Now, if the nuclear charge is more, attraction will be more. If attraction is more, we will require more enthalpy of ionization. It means enthalpy of ionization is directly proportional to the nuclear charge. Greater the nuclear charge, more the enthalpy of ionization. Are you noting down all this?
Yes, sir.
Yes.
Third factor is the penetration effect. Penetration effect means when you talk about the penetration, that means suppose I have an electron in the fourth shell in the 4s or 4p or 4d or 4f. Can you tell me which is more penetrated towards the nucleus? which is more penetrated towards the nucleus? S, P, D, or F? Which comes first towards the electronic configuration?
S.
S. It means to remove electron from the S is difficult as compared to P, and then D, then F. Next, we have an electronic configuration. All those species which have either half filled or completely filled, they are more stable. And to remove electron from it is more difficult. It means completely filled maximum energy is required, then half filled, and then the incompletely filled. Completely filled is the most stable one, and to remove electron from it is very, very difficult. Suppose I say I have a neon 1s2, 2s2, 2p6. It is completely filled electronic configuration. Highly stable, and it requires highest enthalpy of ionization. But if I talk about the nitrogen, that is a half filled 1s2, 2s2, and 2p3. You can see 2p3 is half filled. So half filled will require less enthalpy of ionization. It will require less energy to eject out electron. And any other element like oxygen or carbon or any other element that is an incompletely filled electronic configuration that require less enthalpy of ionization. Am I clear?
Yes.
So these are the factors. So as you go down the group, now you can check in your periodic table how you're going down the group. There are 18 groups vertically down. Atomic size, what happened to the atomic size? Tell me. You're done in the previous topic. It increases, decreases, or remains same?
Increases.
It increases. If the atomic size increases, the electron distance between electron and the nucleus will increase, decrease, or remain same. I'm asking very simple. If the number size increases, the distance between the outer electron and the nucleus will increase, decrease, or remain same.
Increase.
It increases. If the distance increases, the force of attraction between the electron and nucleus will
Increase.
pardon?
Increase.
Why? I told you force is inversely proportional to R. The R increases, the
Okay.
attraction will decrease. If the
Yes.
attraction
Sorry.
decreases between the electron and nucleus, it will become easy to eject out electron. So the enthalpy of ionization will decrease as you go down the group. So we can conclude that as you go down the group, the enthalpy of ionization decreases. Am I clear?
Yes.
Right.
Yes, sir.
Now, if you move from left to right across a period, across a period. If you move from left to right, how does the atomic size vary? I told you in the previous topic. Yes. How does the atomic size vary along a period? Right now we had discussed. Not remembering?
It decrease.
It decreases and respond. Hmm? If the size decreases, the
Yes.
force of attraction will.
Increase.
Yes. If the attraction increases, removal of electron will become difficult, right? Removal of electron becomes difficult. And that is why the enthalpy of ionization decreases. Understood?
Yes, sir.
Yes.
Now, next. Next topic is electron gain enthalpy. Electron gain enthalpy. What is this electron enthalpy? If we have an atom A and we are adding one electron to it, it becomes negatively charged. And a certain amount of energy is released in this case. This release amount of energy is called as a electron gain enthalpy. So you can write down electron gain enthalpy is the amount of energy released. Write it down. Amount of energy released when an electron is added to when an electron is added to an isolated gaseous atom. When an electron is added to isolated gaseous atom. When an electron is added to isolated gaseous atom. Understood? Understood or not?
Yes.
Greater the attraction for electron, greater the attraction for electron, more energy is released. So I can say this electron enthalpy will be more negative. more negative. Right? It means if attraction is more energy will be released and more negative will be electron enthalpy. Negative means more energy is released. So as we go down the group, as we go down the group, what happened to the atomic size? What happens to the atomic size?
Increases.
Increases. So if the number of shell increases and the size increases, attraction for the incoming electron will, what do you think? Will increase or decrease, or attraction for incoming electron will, you tell me. You can see electrostatic F directly proportional to the Q1 Q2 upon R square. So the R is increasing, attraction will
Decrease.
decrease. So attraction decreases. If attraction decreases, less amount of energy will be released. Less amount of energy will be released. Or I can say this electron gain enthalpy decreases. It becomes less and less negative as you go down the group. Understood?
Yes.
Now, along a period. Yes, Hamid. Along a period, how does the atomic size vary?
So along a period,
I'm not getting you.
I'm saying across a period, atomic size decreases.
Decreases. If the size decreases, the attraction for the incoming electron will increase, decrease, or remain same.
Sir, attraction will increase.
If increases. So I can say more energy will be released. Or I can say electron enthalpy becomes more negative. It releases energy. It releases energy. Understood?
Yes.
Right. That is how the electron enthalpy varied down the group. Three topics I had discussed. Number one, I had discussed atomic size. Number two, I had discussed electron enthalpy of ionization. And number three, I had discussed electron gain enthalpy. Any doubt in it?
No.
Any doubt in this?
No, sir.
No. Hamid?
So
Now, next topic, write down. Electronegativity. Electronegativity. Electronegativity means, write down, tendency of an element to attract shared pair of electrons. Tendency to attract shared pair of electrons. Suppose I have a two atoms here, A and B. A and B. One of the two has more tendency to attract electron cloud towards itself. Let it be B. Then the electron cloud will be more close to the B as compared to A. This will require partial negative charge and this will require partial positive charge. Due to this shifting of the electron pair, this becomes polar. It becomes polar molecule. It becomes polar molecule. It becomes polar molecule. So this tendency to attract shared pair electrons towards itself is called as the electronegativity. Suppose I say hydrogen bonded to the chlorine and chlorine is more electronegative as compared to hydrogen. So electron cloud is more close to the chlorine as compared to hydrogen. So chlorine is partial negative and hydrogen is partial positive. This is a polar covalent molecule. The bond is not a polar covalent bond. Am I clear? Any doubt?
No.
No. Next is now write down the group as you go down the group. What happens to the atomic size? Increase, decrease, or remain same?
Increase.
Increase. So for the attraction for electron will,
Decrease.
decrease. So the electron negativity will decrease. So write down as you go down the group, electron negativity decreases. Understood?
Yes.
No. Yes, Hamid, any doubt?
No, sir.
No. Next, along a period. If you move along a period from left to right, if you move along a period from left to right, atomic size Quick response. I want quick response. What happened to atomic size?
Decrease.
Decreases. So the attraction will.
Increase.
So the electronegativity will increase.
Increase.
So as you move from left to right, the electronegativity will increase. Am I clear, Hamed?
So,
Yeah. Okay. Now these are the topics that we had done. Next topic right down here is metallic character. When I talk about metallic character, it means metal tendency to lose electrons. How easily and how many number of electrons it can lose. That is called as a electronegative metallic character. Am I clear? So as you go down the group, tell me, as you go down the group, how does the metallic character should vary? Now you can correlate atomic size, enthalpy of ionization, tendency to lose electrons. You can relate all these things. Hello, are you getting me? Hello, are you there? Hello.
Yes.
Yeah. So now correlate. How do we, if you go down the group, how will the metallic character vary? Can you correlate? Okay, you tell me how does, as you go down the group, how does the atomic size vary?
Increases.
Increases. Enthalpy of ionization will
Decrease.
decrease. So tendency to lose electron will. Tendency to lose electron will. If enthalpy of ionization decreases, it means it can lose electron easily or difficulty. Not getting me. If less amount of energy is required to remove electron, will the tendency to lose electron will increase or decrease?
Increase.
Yeah, so much time to think over such a small simple thing. So I can say the metallic character will increase. Metallic character increases. Getting me?
Yes.
Okay. After this, we are going to discuss these questions, starting with question number 2, right? Try these 3 questions, number 2, 3, and 4, and just give me a minute. I'll be back just in a minute, right? Just try this. I will be coming back. Yes, I'm back now. Have you tried these questions? Have you tried these questions? Hello? Are you there? Are you there? Can you hear me?
Yes.
Okay. Have you tried these questions?
Yes.
Okay, question number 2. Which element do not belong to same family? Here it is a S2D10, 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 but 3p5. This is not for the same family. So the same group, they must have similar type of electronic configuration. But C does not have any d subshell, so it is not of the same family. Am I clear? Yes, Hamid? Hello?
Yes, sir.
Right.
Yes, sir.
Now go to number 3. ionization potential for which set is correct? Let us check all this one by one. You can open your periodic table. Just right now, open your periodic table. Do you have periodic table with you? So I have arranged these elements in the down the group. It means as you go down the group, enthalpy of ionization decreases. Lithium should have maximum, but it is not the case here. So this is not my answer. Is that clear?
Yes.
Now, lithium, cesium, and boron in the periodic table is somewhere here in the same line. So as you go down, the enthalpy of ionization decreases. But here it says the opposite case. So this is not my answer. Am I clear? So I
Yes.
think lithium is the correct answer. The C part, lithium, potassium, cesium. Lithium, potassium, cesium. As you go down, the enthalpy of ionization goes on decreasing. Boron, lithium, potassium, this is wrong again. So C option is the correct answer. Am I clear?
Yes.
So C option, correct answer. Fourth question. In which of the following process highest energy is absorbed? Absorbed means which will be requiring energy maximum. Work upon the question. You can open your periodic table. You can get the atomic number, position, and everything. If you see the first option here, copper, atomic number 29, you can check it from the periodic table. It's a 4s1 3d10. And when I'm removing one electron, I'm removing electron from the 4s orbital. Right? And in the second case, I'm adding electron to the bromine. In that case, energy will be released, not absorbed. So this cannot be my answer. C cannot be my answer because here also energy is released. And D part. In D part. What happened to the D part now? Here it is the 1s2 and 2s1 from where I'm removing electron here. Second shell is smaller and closer to the nucleus as compared to the 4s. So to remove electron from the lithium is more difficult as compared to that from the copper. So highest energy is absorbed in the D case. Understood? Yes or no?
Yes.
Electron affinity for inert gas is positive. Electron affinity means electron gain enthalpy. Remember, electron affinity means electron gain enthalpy. It is positive because if I add electron to the neon like noble gas, I will be adding electron in the next shell. Neon has already electronic configuration 1s2, 2s2 and 2p6. And now I'll be adding electron to the 3s subshell. So already existing electron will be repelling the incoming electron, and that is why it is positive. We have to provide energy, right? I'm stopping sharing for a minute. Right. Now tell me, do you have any doubt till now,
No, sir.
Ahmed?
So,
Are you getting, Ahmed?
yes, sir.
Okay. If you find difficulty, you can just let me know. I'll explain again. Now, coming back to the question here. The 10th element of the periodic table resembles the element with atomic number. The 10th element of the periodic table. 10th element means atomic number 10 is neon. Can you see that in the periodic table? Atomic number 10 is neon. Resemble with which atomic number? It means in the same group, all the elements should have same property. Now you can check it from the periodic table. Which atomic number are in the same group, like atomic number 10?
Atomic number 18.
8 and 18, right? Now, which of the following remain unchanged on descending in a group in the periodic table?
Density.
Unchanged. Number of valence electron remain unchanged. Can you see that as you move down the group, the number of outer electron remains same. In the group number 1, there are only one electron outermost shell. See, we have done here in the very beginning of the today's class. This one. You can see as you go down the group, the valence electrons means the number of electrons which are in the outermost shell, that is same. So I can say the valence electron remains same. So valence electron remains same. Am I clear?
Yes.
Now, an atom has electronic configuration in which place, in which group it is. How to find the group number, right? The last electron you can see is entering into the D subshell. Now I'll tell you a trick how to determine the group number or period number. How to find the group number and period number. When I talk about the period, let it be if I give you atomic number 19, tell me its electronic configuration quickly. Now I'll tell you how to identify the group number and period number.
Argon for S1.
Argon 4s1. Good. This 4 is the highest quantum number and it tells about the period number. So period number is equal to 4. And block is S because last electron enters from the S subshell. And this 1 means it's a group number. Group number is equal to 1. If the last electron enter into the s subshell, this is how we determine its position in the periodic table. You can check from the periodic table. Is it there where I'm telling you? You might have periodic table with you. So check from there. Atomic number 19 is at this location or not.
Yes.
Now, if I'm giving atomic number 33, write its electronic configuration. Yeah, I'm waiting for response. Argon complete. 4s2, 3d10, 4p3. Yes or no? Hello?
Yes.
Now, this is where the last electron goes. So period number is equal to 4. Block number is equal to P. And for the group number, remember S electron and P electron are outermost shell plus 10. It means 2 plus 3 plus 10 is equal to 15. So group number is equal to 15. Understood? Yes or no? Note it down. Ahmed,
Yes, sir.
note it down. Understood?
Yes, sir.
Right. Similarly, if I'm giving atomic number 26, write its electronic configuration quickly.
Argon 3D5 or S2 3D1.
4s2 3d6. Check your electronic configuration. 18, 20, 26. Got it. So we are filling last electron here in the 3d6. So period number is equal to 3. Block is D. And the group number in case of the D will be equal to S plus D electron. So 2 plus 6 is equal to 2 plus 6 is equal to group number 8. So this element belongs to group number 8. Am I clear?
Yes.
Now come to this question here. In which group? So see, the electron is in the last electron, the 3d3. 3d3, D subshell. So group number in case of D subshell is equal to S plus D electrons. So 2 plus 3 is equal to 5. It means answer is the fifth. It's the fifth group. Am I clear?
Can you explain it again?
If you see this electronic configuration, and you can see the last electron is in the 3d3. See? And I just now told you that the group number of those elements in which the last electron goes into the D, then the S electron plus D electrons are added in the outermost shell. So 2 plus 3 is equal to 5. So group number is equal to 5.
Okay, thank you.
Number 9th question now. The correct decreasing order of first ionization enthalpy of the 5 element of the second period is, see, beryllium, boron. Beryllium of course will have more. But if I compare the boron and carbon, the carbon should have more, nitrogen should have more. So that should be nitrogen, fluorine. No, fluorine will have maximum because of more nuclear charge. 7, 6. This is the completely filled electronic configuration. So C option is the correct answer. Are you getting me? Number 9th question.
Yes.
The element with a positive electron gain enthalpy is, which element has a positive electron gain enthalpy among these? Yes. Right now I told you that noble gases have a positive electron gain enthalpy. So neon will have a positive electron gain enthalpy. Understood? Ahmed?
Yes.
Ahmed, are you there?
So
Okay.
I got disconnected a bit. So can you explain again?
Question was here, which has a positive electron gain enthalpy. It means
Yes.
in which case we have to provide energy to add electron. and that is a noble gases. The noble gases here. Near is a noble gas here, right? Okay. Now come to this question, number 1. These are isoelectronic. Can you tell me what is the meaning of the word isoelectronic? Yes, tell me. Yes, Niranjana. Last time I discussed with you.
They have the
Last time we discussed what is electron.
they have the same number of electrons.
Yeah, same number of electrons. So these elements, all of these elements has how many electrons? Can you tell me? Can you tell me how many electrons are there? In case of sodium ion, magnesium ion, aluminum ion. If I tell you atomic number of sodium is 11, magnesium is 12, 13 and 14. Not tell me the number of electrons in these cases. In case of sodium, how many electrons are there?
10,
10. 1 electron loss. Magnesium,
10,
aluminum,
10,
silicon.
10.
So I can say all of them have the same number of electrons. And that is why I call them as they are isoelectronic. If all of them have the same number of electrons, they are all isoelectronic. Find out the nuclear charge per electron. 1.1, 1.2, 1.3, 1.4. And I told you that more the nuclear charge per electron, smaller the radii. It means the correct answer is, you tell me now, which is the correct answer? Now you can compare very easily. Amit, you're thinking so much. More the nuclear charge per electron, smaller the radii. And I have given
Yes,
you
yes, I
all
don't.
this. I have given you all the Z upon E value. Yes,
Yes, I didn't get the answer.
okay. Now tell me, I said more the nuclear charge per electron, smaller the radii. Which among this has the highest value of the Z upon E value? 1.1, 1.2, 1.3,
Sure.
1.4. Which is the highest
S
value?
SI4.
Yeah. So it has it will have a highest Z upon E value. So radii will be smallest. Yes or no?
Okay. Yes, sir.
So now on this basis you compare it. Yes, Niranjana, work upon it.
Is it option C?
Good. Z upon E value is minimum it means radii is maximum. Getting me then, Ahmed?
So,
No. The C option correct answer. Consider these changes here. We are removing electron, energy is E1. Then from the positive, we are removing another electron, E2. What is the correct relationship? Which will require more energy, E2 or E1? Okay, I said like this. Suppose I say I have a sodium here and I have lost one electron. Some energy is required here, and that is the E1. And from the sodium positive, I am removing one more electron to make it 2 positive. It is E2. Now, can you tell me which will be greater value, E1 or E2?
E2.
E2. Why so? Why E2 greater than the E1? On what basis you have said this?
Loses more electrons.
Repeat.
It loses more electrons.
Your answer is not clear. Repeat.
It loses more electrons.
So what will happen to the energy? See, in case of sodium, I have this electronic configuration 1s2, 2s2, and 2p6, and 3s1. It means I'm going to remove electron from the 3s1. But once it has lost one electron, now the electronic configuration is now 1s2, 2s2, and 2p6. This acquires a noble gas configuration, a stable electronic configuration. And to remove electron from a stable electronic configuration, it requires more amount of energy, and that is why I say E2 is greater than E1. E2 is greater than E1. Am I clear?
yes, sir.
Now, which pair of element to the same group? Which pair element belongs to the same group? You can check from the periodic table also. Otherwise, you can determine their group number as I have told you, and then correlate which will have the same number of groups.
Sir, option C.
Option C.
See. Fluorine, chlorine, bromine, iodine, astatine. Atomic number 9, 17, 35. It must be 53 for iodine. Yes or no? So see. Okay. In the given energy level, the order of the penetration of the effect of the d orbital is, which is more penetrated towards the nucleus. Ah,
Is it option A?
good. Which of the following sequence correctly represent the decreasing acidic character of oxides? decreasing acidic nature of oxides. For this question, I will tell you very simple basics first here. I'm coming to the question later. First, you come to number 6. Fifth, I will could discuss later. Highest energy is absorbed. I think this question we have already done in the previous assignment. Yes. First three ionization energy is given here, P, Q, and R. Then the incorrect option is the Q is alkaline earth metal. Yes, because after losing these two electrons, there is a sudden jump of the E3. The group alkaline earth metal means group number 2 element. So they can lose two electrons easily, and a third electron removal is very, very difficult. So this statement is correct. My question is which is the incorrect statement? P is alkali metal. Yes, because after the loss of one electron, there is a sudden jump. Alkali metal means group number 1. The statement is also correct. S, R. R is a S block element. Element. Yeah, they are very comparable energy. This is also correct. They belong to same period. No, not necessary. This is not necessary. So D is the correct answer. Okay, eighth question you can do very easily. How does the atomic size vary for these elements? You can use the periodic table. You have periodic table in front of you. From the periodic table, you can judge very easily. These are the elements here. Arsenic here and a periodic table oxygen, sulfur, selenium is there. As you move down the group, the size increases and along a period decreases. It means arsenic should have more size as compared to the selenium, then sulfur, then oxygen. This should be the correct answer. Yes or no?
Yes.
Number ninth question. Yes, what have you concluded? This is incomplete question. Data is not clear. Leave that. Come to this question number 10. Which involves maximum amount of energy? It's a very simple question. You can apply now.
Option D.
Option
D.
D. Yes. It is maximum positive. So to remove electron from the positive require large amount of energy. Now I'm coming to that question where we left number 5. These are the different oxides are given, right? And we have to arrange them in their decreasing order of the acidic character. Understand here. Lithium oxide, sodium oxide, potassium superoxide. These are the oxides of the group number 1 element. If it dissolve in water, they will form lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. Right? These all are basic in nature. When these are basic in nature, they can give the OH ion. It means all these are basic in nature. And as you go down the group, this metal and OH bond becomes weaker and weaker because atomic size increases. As you go down the group, atomic size increases, bond becomes weaker, and tendency to give OH ion increases. And that is why the basic character increases as you go down the group. Am I clear? So as you go down the group, the basic character increases of the oxide as well as the hydroxide. Let me know. Have you got it or not? Have you got it or not? Should I explain again?
No, so I got it.
Niranjana?
Can you explain again?
Okay. You can see that these hydroxides are basic in nature because they can give the OH ions. Metal and OH bond. As you go down the group, the atomic size of the metal increases. If the size increases here, the bond becomes what? Weaker. We can break the bond easily. It means it can give OH ion easily. So I can say as you go down the group, the basic character increases. Of the hydroxide as well as for the oxides.
Okay.
Now, if you move from lithium oxide to beryllium oxide, or B2O3 or CO2, these are moving along a period, When these are dissolved in water, they give lithium hydroxide. It'll give beryllium hydroxide. This will give boric acid. Its name is boric acid. This is a carbonic acid, H2CO3. It gives nitric acid. As you said, nitric acid, carbonic acid. As you move from left to right, what is happening is the acidic character increases. Acidic character increase. So as you move from left to right, the acidic character increases, but as you go down the group, the basic character increases. Understood? Yes or no?
Yes.
Now, coming to this question now. You do it.
Is it option B?
Good. Okay. Now, next, write down another topic now. Diagonal relationship. Diagonal relationship. In the diagonal relationship, check in your periodic table, period number 2 and 3. Here we have a lithium, sodium. Here we have beryllium, magnesium, boron, aluminum, carbon, silicon. These elements which are diagonally placed in the periodic table, they have same properties. This resemblance in the physical and chemical properties of these elements which are diagonally placed is called as a diagonal relationship. Those elements which are diagonally placed in the period number 2 and 3, they show the similarity in their physical and chemical properties. This is called as a diagonal relationship. Understood? Now
Yes.
we are going to discuss about what is the cause of the diagonal relationship. Quickly tell me, quickly. Down the group, atomic size. Increases, decreases, or remains same?
Increases.
Increases.
Decreases.
If you move from left to right,
Decreases.
decreases. And if you're going diagonally down, it means we are going down as well as going from left to right. If you go down, size should increase. If you go from left to right, size should decrease. They cancel out the effect of each other and they have almost equal radii. Am I clear?
Yes.
Yes.
Right. Now, what about the enthalpy of ionization down the group?
Decreases.
Decreases along a period.
Increases.
If you go diagonally, they will cancel out the effect of each other.
Yes.
Yes or no? So any
Yes.
property which is going down the group and along a period, they are going inversely. They are going opposite. If you go diagonally, that will remain constant. So first reason is this one, that the physical property like atomic size, electron enthalpy, they are their variation is just opposite down the group and along a period. So if you go diagonally, they cancel out the effect of each other and they have similarity in the physical and chemical property. Number two, they have same polarizing power. Polarizing power. What is polarizing power? Size upon radius. Charge upon radius. The charge and radius, that is same, so they have same polarizing power, and that is why they have similarity in their physical and chemical property. This is called as a diagonal relationship. Am I clear?
Yes.
Diagonal relationship. Now, I'm talking about the reactivity. When I talk about reactivity of metals, then we talk about metal, how easily they lose electrons. Metallic property, metallic reactivity is measured in terms of how easily they will lose electrons. So as we go down the group in the metals, like the S block element, lithium, sodium, potassium, rubidium, cesium. Down the group, atomic size. Give me a quick response. As you go down the group, atomic size
Increases.
increases. Enthalpy of ionization,
Decreases.
the tendency to lose electrons become easy.
Increases.
It become easy. It means the reactivity will increase down the group. You can write down reactivity of metals down the group increases. Reactivity of metals down the group increases. Am I clear?
Yes.
And reactivity of non-metals now. Like we have a fluorine, chlorine, bromine, iodine. Its reactivity is measured in terms of how easily they gain electron. Write it down. This reactivity depends upon tendency to gain electrons. So as you go down the group, the atomic size, tell me what happened to atomic size?
Increase.
So um, electron gain enthalpy will decrease. It means attraction for electron will decrease. It means they don't want to lose electron. They don't want to gain electron as you go down the group. And that is why the reactivity decreases as you go down the group. It is just opposite to that of the metals. It is just opposite to that of the metals. In case of the non-metal, the reactivity is measured in terms of how easily they gain electron. And in case of the metal, it depends upon how easily they lose electrons. Am I clear?
Yes.
Any doubt you want to ask?
No.
Right. So we had discussed the complete chapter and we discussed the assignment also, right?
Yes.
Anything that you want to ask, you can ask me. Otherwise, we can end the session now. No questions?
Everything's clear.
Nothing is clear. Okay, then. I'm ending session now. See you now on, I think, and the next class is also being scheduled. We'll let you know, right? Okay, then.
Yes.
Goodbye for now.
Thank you.